William Gibson has a quote, "The future is already here, it's just not very evenly distributed." In enterprise IT, we look around and we see Amazon, we see LinkedIn, we see Booking.com, we see these companies that do these amazing technical feats, and we think, well, I don't have the scale or I don't have the team to build all that tooling to do the same things. And my goal here is literally to kind of spread this around. There are practices you can actually take away with you, which have been around for a decade or more, which you can mimic even if you're not one of these giants, right? So you're going to leave here today with 3 takeaways that you can use to adapt your own practices, whether it be to adapt systems you've built in-house or plan to build in-house, or whether you're going to be kind of shopping for something to sort of fill in the gaps. And my goal is just to leave you more informed and educated about what's already out there so that you can actually adapt it. The title of the talk today has the word experimentation in it, right? Experimentation for speed, safety, and learning. And I want to define experimentation this way, which is it's continuous delivery with control and observability built in rather than ad hoc. And I make the point, remember why we do continuous delivery. So continuous delivery or continuous deployment, the idea is I want to get ideas out to some place I can validate them much faster. I don't want to wait 6 months between I think we need this and is this okay, customer? I want to go much faster. And you'd say, well, that's an agile thing. It's agile or it's Scrum. It's modern software, which is that how do I reduce the time between idea and delivery so that I can find out more quickly whether it's working. And a lot of the steps in this is to automate. Like if the build is something you do manually, we had a build manager 5 companies ago who literally, we're doing a build on Thursday, and everybody had to get their stuff in, and that person was crazed for 48 hours while they made sure everything would come together and work and didn't, right? Now you change your code and a build server kicks in and Jenkins or something takes over, and before you know it, you know where it works or not, and with much less scramble, right? So we do continuous delivery so that we can try something and get feedback. And people have focused on the try, do, but the feedback is ad hoc. I ask people, so how do you find out how it went? Well, we look in the logs, or we do some database queries, or we have some analytics here and some analytics there. And how often do you do that for every little change you do? Oh, no, we wouldn't do that for every little change we do. We do it if something's obviously broken, or if there's some huge thing that we're trying to brag about, but otherwise we don't really have the time to look. Right? So that kind of breaks the whole idea of trying to have a feedback loop. So what do we mean by continuous delivery? And we'll have like a textbook definition, and then we'll have a more fun definition that we can maybe jump out to the bar about, prove later. Continuous delivery, so Jez Humble writes a lot of great stuff, and he defined it like this: the ability to get changes of all types, including new features, configuration changes, bug fixes, and experiments into production, or at least in the hands of users somehow, safely and quickly in a sustainable way. So sustainable, again, is about like automation and patterns and not having to reinvent the wheel and have a drama and have a not coming home for dinner kind of thing. The other way he defines this is what he calls the Mojito test. Has anyone here heard of the Mojito test? Okay, no show of hands, but that's fine. So the Mojito test is pretty straightforward. Jez says that if you're doing this right, you should be able to hold a Mojito in one hand and push a button to push the latest version of your code in your repository into production with the other hand, and you should be able to relax and enjoy your Mojito. And ideally, you could be able to do this at 4:30 on a Friday afternoon. It's happy hour, let's have a Mojito, like I'm just gonna push the latest code to production, it's all fine, right? And lots of laughs and giggles, you're like, yeah, that's, some people actually are so dialed into what they're doing and have things so automated that they can actually approach the Mojito test. Right? So that's continuous delivery. So, but what sort of control and observability are we talking about here? That could be a lot of things, right? So this is an image of sort of a continuous delivery pipeline. And it's not blown up big enough. Don't worry about trying to read the steps. It's just this, which is I check in code, and then maybe a test runs, and if there's a problem, maybe I'm told, and I make an edit, and I check it back in, and that test passes, so something else happens, and and the build happens, and then you go through various environments, and eventually you get to production, right? So that's a continuous delivery pipeline. Actually, that's not what we're going to talk about. That's like, how does my pipeline run? And observability, do we mean observability of the pipeline itself? And this is a screenshot of something called Hygia, which was built at Capital One, and they've given it away open source. Those steps in there, again, I didn't blow up the screenshot, but they're just basically how much time does your code spend in commit and build and this kind of test and that kind of test. And you know, the performance test one, of course, is the biggest box. It takes days instead of minutes. And then the very last box is how long has your code been in production? How many days has it been since we had a push to production, right? And so this would be like, I'm trying to keep track of how everything's moving. But nope, that's actually not what we're talking about. What we're talking about is actually something more fundamental. So if we're not talking about the pipeline, what are we talking about? Well, the payload. Like, why are we doing this in the first place? Like, what is it that the user is actually going to see or experience, or the customer is going to smile or not smile about, right? I wrote this, which is whether you call it code, configuration, or change, it's in the delivery that we show up. Like that, when you deliver, you show up for others. And people live in fear of doing a delivery which breaks things, right? You don't really want to like push some software into production and have everything go down. We want to deliver and have people be delighted, or at least not notice when something's wrong. And so that's what we're going to talk about, right? So control, in this sense, is really control of exposure. Who is going to get the code when? How do I control who sees it? And how do I make that control something that's selective? And you'll hear terms like blast radius. Has anyone heard about limiting the blast radius? Yeah, some nods out there. Limiting the blast radius. So, you know, it's kind of a scary warlike thing, but when a bomb blasts, you know, there's a blast radius that goes out like this. And Microsoft actually has this notion of concentric circles. And if you ever use a Microsoft product, in the updates, you can configure what kind of a user you are. Oh, I'm an early preview user, or I'm a, hey, you know, make sure it's all stable user. There's like steps you can put in there, right? And to go from the first ring, they call them rings, to go from the first ring to the outermost ring might take 3 weeks or more at Microsoft, because they're kind of going through the motions and making sure that everything's cool, right? So that's blast radius, right? Another way to look at it is really the propagation of goodness. If you're making a change, let's say some people are saying, I need this, I need this, I need this, I need this. Who's going to get that change, right? So how do I control who gets the thing I just did? And maybe I'm sending it to my friendly customers. Maybe I'm sending it to somebody who is contractually obligated, you know, we have to get it to them or whatever. And then the last way, which I really like to define this, is the surface area for learning. Because remember, the point we're making here is that we're trying to figure out how do we build stuff and get feedback quickly without drama, right? And so what's the surface area for learning? How do I control where we're learning from? Just a little area is probably not a good thing if you need to make sure that this meets the needs of a lot of people, right? But if you're trying to figure out whether something is really brutal on the CPU, you probably don't want to ramp it up to all your users right away, right? So there's some ways to do this. So here's some key things, and we'll go back to the takeaways, but in terms of this, how do I decouple deployment from release? How do I make it so that deploy is not the same thing as release? A lot of people think that when you deploy to production, well, you've deployed to production. It's there, oh my God, like oh, the users, right? Because we think that they're one and the same a lot of the time. But if you can decouple from deployment from release, then deployment is really just infrastructure. It's just moving bits around, right? And release is when you choose to expose things to users, okay? So this is the first kind of like, for some of you, like paradigm shift thing, which is what if I push the code all the way into my data center where millions of dollars are transacting, but no one saw it and it didn't execute? Like, is it really there or not? Well, it's there, but you haven't released it yet, okay? And the converse is true, and actually kind of more importantly true. How do I decouple reverting from rollback? Like, if there's a problem, how do I actually just say undo? Not, oh, wow, we got to restore, I'm going to kill those, you know, I got to bring back up the other environment, or, you know, how do I not have it be drama? How do I have it be like a button? I push a button and I say, oops, and now everything's back to where it was, right? And you'll hear about blue-green environments, which is the idea of having parallel environments running, and you bring up a duplicate of your entire infrastructure, and you don't put anybody through the new version until you've got it all up there and you think it's ready, and you leave the old one there in case something goes wrong, and you start filing people through here, and if it gets ugly, you bring this down. Well, that's a lot of duplication and cost, right? What we're going to talk about here is actually much fewer moving parts and much cheaper. So feature flags. Show of hands, who has heard of feature flags before today? Okay, a lot of you. Okay, which is great. Feature flags, sometimes I'll mention this when people say, yeah, so when we compile the software, we have a flag which determines what the output of the compile is, right? That's not a feature flag, that's a sort of build time flag that controls this fixed object you end up with. And they'll say, oh, well I have, feature flags. When I launch the server, I have a command line argument that turns this on, and that server is in experimental mode, or it's doing the different thing, right? No, that's a server configuration thing. That's not really a feature flag. And the last example you hear is, well, I've got this configuration file. We read it every 90 seconds. So all I have to do is push a new version of that configuration file, and the server will change what it's doing. Again, that's at a server level, right? That whole server is doing that. What we're talking about is user by user switching what happens dynamically to users as they pass through the code. So you've got a code path that's maybe new, and you decide, do I send people down the new code path or not? And you want to be able to control this all the way down to the level of a single user, but also be able to use populations, aggregations like all my beta people or all my internal testers, or whatever, right? So in this diagram on the right, you see, first of all, I see a knob turning it up and down. And then you see that the first line is 0%. If I'm doing a rollout, why would I roll out to 0%? Right? And the short answer is because it's not ready yet. Right? And if anyone's heard of trunk-based development or monorepo, the notion of having only one version in source, not lots of feature branches, but actually having one branch that everything lives on. In order to pull that off and actually not have things break in production or people see half-baked features, you need the ability to push a feature all the way to production, but have it dark, have it off, have it latent, have it not there. Right? So that's the 0%. And then you see the 10% and the 20 and the 50. And, that's the notion of ramping it up a little bit at a time and kind of watching it as it goes and deciding whether it's okay. Right? So there's another use case, though, which is you're deliberately trying to run an experiment. I mean, everything we do is kind of an experiment when you think about it. Like, okay, we're going to deploy. Did it go okay? Right? But when you're truly trying to say, you know what? I need to know whether presenting 5 options to the user instead of 3 options is going to be better for us or not. Or I need to know whether this new search algorithm that the people are so excited about really is going to work, it's not going to tank the server, or people are going to like the results or whatever. So you might literally have a legacy search algorithm and 2 once you're trying, and you're going to route traffic and put 80% of the people through the legacy and 10 and 10 through the 2 new ones to kind of see what happens. That's an experimentation example, right? And in this case, we're splitting some population 50-50, but that doesn't have to be all your users. It could be, you know what, within my beta testers, I'm going to give half of them this. Or within my free users, I'm going to give half of them this. Or within my people that don't have contracts that say if I hurt them, I owe them millions of dollars. Whatever, right? But you're going to split the population, right? And the first card there you see says tasks created per user, and it says there was a statistically positive impact of 11%. So yay, it's green. We've accomplished something. But what if, while we were doing that, we actually tanked performance? Like the page response time went down by 25%. So now we're only doing this to a small number of users, and so far they're not like fleeing in droves. But if we know this, we might say, you know what? Even though this is working to get more tasks, we might want to pause here and actually fix the performance issue before we ramp it up, right? Again, a lot of these concepts are not like deep theory. We don't have to actually call this a course, PhD course in technology to understand that. It makes sense, right? So, but the problem is that those boxes, most people don't have those boxes, right? Those boxes are the result of having a data analyst dig around in mine, or an operations person look through the logs, or looking in Datadog or whatever, and it's all very ad hoc. So the first thing we said at the beginning was, how do we do this and not have it be ad hoc, right? How do we make this just kind of automagic? So here's what a feature flag looks like in code. I've given a really simple kind of pseudocode example here. Treatment equals flags.getTreatment related post. So this is an example of an on-off example. If the treatment is on, if that function call to get treatment comes back with on, then I'm going to show related posts. And if it comes back with anything other than on, I'm just going to skip this. I'm not going to show the related posts. So that's a super simple on-off example. Multivariate, this is the one I kind of gave about the search algorithm, right? Which is get treatment for search algorithm. If the treatment is V1, do that, V2, do that, else use the legacy. And what you don't see here is that function call carries with it the user and the context, however much context you want to send. So who is this, and what do I know about them that I want to use to make my decision, right? Could be a level of customer, could be how long they've been on the system, who knows, anything you want, right? So that's what it looks like in code. So then let's just do a quick kind of switch to what do I mean by observability. So observability has a lot, it's kind of a term that's on the rise lately, and some people say, well, that means writing really meaningful messages to the log. And some people say, well, that means having a really cool tool that can do this stuff in near real time without any delay. And simpler than that. What I'm saying is, for observability of exposure, I want to know, who have we released this to so far? We had an intention, which was we configured it to say, oh, I'm going to my East Coast users who are beta testers, and I think I'm going to have about 1,000 people if I do that, or 100 people, or whatever. I want to be able to see who actually has seen this and who hasn't. Like, who came through the switch and got one thing or the other, right? So that's observability of who's seen it. And then this is the really important part, and this is the part that almost nobody has. Some of the most sophisticated companies I talk to will say, so how do you know how it's going? Like, well, again, we dig manually, right? So how is it going for them and for us? So how are the customers doing? Are they doing more of what you wanted? Are they leaving? Are they unsubscribing? Are they buying more stuff? Are they, bouncing? And how's it going for us? Are we getting more errors? Are we getting, are we using more capacity? Are we actually burning through more server capacity with something that wasn't supposed to? How's it going for them and for us? So that's what I mean by observability. And these are kind of on the surface really simple questions, which is who's got it and how's it going, right? The devil's in the details. How do I figure out, how do I keep track of who's got it if I'm just routing people through different servers or whatever, right? So here's the meat of the talk. This is the who already does this well and is generous enough to share how. So this is the part where I'm kind of saving you a lot of research. Everything I'm going to show you is actually available, and there's links in my presentation, which I'll share later, if you wanted to go read the details yourself. So the first one is LinkedIn, and they have something called, if you guessed by the acronyms, XLNT. Right? And LinkedIn, we'll start with their humble beginnings. So they knew that they needed the ability to try things out and not break everything for everybody all at once, right? And I think a lot of us have something along those lines, right? So they built a targeting engine that could split traffic between existing and new code. And I was watching a video, they're kind of explaining this process. And impact analysis was done by hand, and it took about 2 weeks. So if you could beg a favor from a data scientist, you'd get an answer in about 2 weeks for whether your thing really did the thing you wanted it to do, right? And as a result, pretty much nobody did that, because that's a big favor to ask, and it's a long time to wait, right? So essentially, they just had feature flags. They had the ability to make the decisions, but they didn't have the automated feedback. Fast forward to today, and they do a controlled release with automatic built-in observability every 5 minutes. So about 100 of those a day, where they don't have to do any ad hoc thing. They just follow the patterns they've built, use the internal platform they constructed, and they do this all day long. And then the bottom part of the screen where it says metrics you follow, that's, I don't know about you, but that's a fairly decent looking UI. That's an internal system, it's not somebody's product. This lets non-technical users or technical users search for metrics they care about and basically subscribe to who's messing with those metrics. So if I really care about newsletter subscriptions, and I've got 40 development teams, or 5, whatever, or 3, and I want to know anytime somebody launches an experiment which is moving the needle up or down for subscriptions. So if I subscribe to this thing, metrics you follow, and I say I care about subscriptions, I might get an email or a Slack or something that says, hey, Tony's running an experiment, and for the people going through his experiment, 30% fewer of them subscribe. Or, wow, he's doubling the subscription rate, right? And you get to know this sort of proactively, you get to be notified. So this is a very advanced, so they're way ahead, talk about the future. They've gone to they've been doing this over and over again, and they don't want to have DBAs and people taking requests to set an alert for me when something blah, 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 right? They want to make this easy and automated. So they're where I learned the word guardrail. So guardrail metrics, that's a picture of a guardrail on a road, right? And what's its job? The job is if you kind of get a little crazy and the car starts to go off the road, you'll bang into it and you'll know, before you fall off the cliff, you'll kind of go ka-thump and you'll stop, right? And the idea behind a guardrail metric, we saw that earlier, which is, if your team is working on something, what are they going to try to optimize? They're optimizing the thing they're working on. So your job is, and it is their job, to focus on making this one thing better, right? It's generally not thought to be their job to, and oh, by the way, and also watch all other things. But if you give that as an assignment to a developer, that's crazy, right? So a guardrail metric is the idea of deciding as an organization, what things do we always want to keep track of without anybody having to work to do it? For instance, you have metrics in your organization. Could be response time, could be failure rate, could be business metrics like unsubscribes, whatever, purchases per user, per hour, whatever. There's a metric, right? So guardrail metrics are those metrics which the local team is probably not focused on, but which if they knew they were hurting, they would probably say, oh, oops, I better not break that, right? Think about it, what would sort of make the directors and the VPs and the C-suite be unhappy, right? So in that example I gave, if the load time's going up 25%, you probably got to take a second look at your thing before you roll it out to your whole population. So that was kind of the journey of LinkedIn. And then Yazoo, who's the head of data science there, she started out as an individual contributor, and she kind of rose to running this whole team. I believe there's over 100, maybe 200 people on her team now. And she boiled it down to some lessons you can take away, right? So first of all, build for scale. They used to literally coordinate these experiments over email dialogues, right? So, hey, and by the way, when they started, they used your user ID last 3 digits or 2 digits, right? So when you became a LinkedIn member, you got a unique number, that they had internally. You didn't know about that, and it just so happened if you were, if your number ended between this and that range, you got a lot of experiments, and if it didn't, you never got an experiment. And then they would argue over which range each team could use for their experiment. I want 37 through 45 or whatever. I don't know the numbers, but they basically had this because they didn't want to collide with each other. And they realized that that's not going to work when you're trying to. Their goal was we want to be able to do 1,000 of these at the same time, and you can't do that if you're debating over email. So the other thing was they had, in their early days, they had some issues, which was they would run experiments and people would come in and the experiment would say, awesome news, 50% change in the good, you're a hero. And they'd go home and they'd tell their wife, and I was like, we're weird rock stars. And they come in the next day, hey boss, check it out, let's look at the results. And they bring up the screen and it says, bad news, you're 50% down. And they're like, but wait, and they had these kind of flapping, and they had all sorts of other issues where people didn't trust the data. Like if you had data like that, you'd be like, yeah, I don't think I want to use that tool. Like I don't think that's going to help me prove my case, right? So they realized they had to make it trustworthy and had to make both the targeting of who got the treatments and the analysis had to be defendable, had to be repeatable, defendable. People had to believe it, right? And we'll see how that has an impact in a sec on your ability to kind of roll this out throughout your team. And then design for diverse teams, not just data scientists. So who here has ever had some really awesome thing in your shop that only one person knew how to use? Right? Usually there's a wizard. There's like, I was selling, shift left performance testing, and we went to a bank and they said, oh no, we're getting out of the choke point of a centralized testing thing. We're moving to this open source stuff, much like what you're building, but we're building it ourselves. And we don't really have a reporting front end, but Bob over here, he can actually get the results to any test and analyze it and share it with teams. And I said, yeah, you realize Bob's going to be a little bit of a bottleneck. Right? So if there's only one person or a small group of people that know how to do a thing, then inherently there's going to be a bottleneck. And one of the key principles of sort of Agile and DevOps is how do I eliminate constraints? How do I make it so there aren't handoffs, there aren't waiting, there's not stuff queuing places? Like how do I make the team autonomous so they can actually get their work done without having to wait on somebody else, right? So design it for diverse teams, not just data scientists, so that anybody who wants to use this can get their hands on it and roll. So the last thing I'll share from LinkedIn is this thing they came up with, which is that everybody wants, and I know we come from different environments, but one of the models people are moving towards is local autonomy of teams, right? The more a team is sort of autonomous, they'll like their job better, and frankly, they'll spend less time waiting for other people. And so how do I balance the idea of giving people autonomy with the need for some kind of consistency so the data will stick? And if every team had a different way of deploying and measuring, then they're not going to believe each other, or they may run into issues, right? So what they came up with was that you really need to have a single way to do this with well-published guidelines that are easily read in a few minutes. When you do, then your ability to have the observations be trusted and understood across the organization goes up exponentially instead of a he said, she said, that team, this team, whatever, right? And obviously, if you can get people who are less technical, who would normally weigh in and veto things without understanding them, to actually believe the system, then you end up with letting the data do the talking, not somebody's opinion. Show of hands who's heard of HIPPO, highest paid person's opinion? Right, okay, so, it's nice to have clarity in a situation where there's chaos, but you don't necessarily want somebody who has the most money in their paycheck being the one who says which technical decision you should go with. It doesn't always go well for everybody. So shifting gears. Have a little sorbet, cleanse your palate, take a little break, breathe. Booking.com. Who here has used Booking.com? And knows it, right? Because actually they own things that aren't called Booking.com too. But yeah, so at least half of you raise your hands. Booking.com, headquartered in Amsterdam, very tech forward, really do a lot of cool stuff. And they're very public about it, which is awesome. So they actually treat everything they do as an experiment. They don't decide to run an experiment and then do something different. Every time they push any kind of change to their infrastructure, to their code, their app, anything, they wrap it in an experiment, right? And we'll see how that worked out for them. So they have 1,000 of these running on any given day. They're not starting 1,000 a day, but there's always about 1,000 of these running at any one given time, right? And they see observability through two sets of lenses, which is really kind of a brilliant expansion of what the LinkedIn guys were talking about, which is, first of all, it's a safety net. So they want to be able to watch so they can quickly detect if something is going wrong so they don't do a lot of it. And I mentioned that, right? The second one is to validate ideas, which you might think of as more like traditional experiments, A/B testing, whatever. Like I've got this hypothesis, I want to validate it. But they do both of these things. And we'll go into a little more detail on the circuit breaker one, which is pretty cool. So this guy, Lukas Vermeer, is head of experimentation there, and he does a lot of awesome public work. He does talks, he does videos, he writes papers. And so he talks about it this way. So experimentation, for the first value is this asynchronous feature release. How do I decouple deployment from release, right? That is far and away the greatest value they get from their experimentation platform, is that no user is impacted at all by pushing a change until they decide to start ramping it up, right? So no impact on user experience. They can deploy more frequently with less risk to the business and user. So again, if you think you're going to hurt things, you're going to be more reluctant to try things, and you'd be slower, put more time into double checking everything. The big win is agility. So they actually figure that they actually move around and change their strategy and do new things much more often because it's not so scary. So next thing, experimentation as a safety net. And this is where it gets really interesting for me. So every new feature is wrapped, right? And they can monitor and stop any change. And remember, they believe this local autonomy thing, which is if the team has autonomy, if you've made a change, who's going to know best what's supposed to happen? Well, the team that built it should know what should the expected behavior be, right? Not some operations person or QA person that's in another building or whatever, right? There's an operations QA person, they better be on the same small team, because those people are going to understand, what are we doing this week? Why did we push this release, right? So they really believe in having the team be the one that watches it and enables and disables it, regardless of who ends up deploying it or who had anything to do else with sort of the infrastructure-y part. So this part is the part where each of these companies has kind of the thing where they've done this over and over again, and they've gotten even cooler about what they do. The circuit breakers have active for just the first 3 minutes of the release. And what it does is it watches for things that are glaringly wrong. And when it sees things that are glaringly wrong, some severe degradation, right? They automatically abort that. And you might say, but wait a minute, the team is supposed to make this decision, right? Well, no, you know that if half the people going through this flow you just started to expose people to get an error, that you can turn it off for now and figure it out later, right? And so that is indeed what they do. This is a divergent from their normal culture, but it's kind of a no-brainer if users are being impacted. And what's really, really crazy, and I don't promise you could pull this off in your own environment, is that the time between starting to expose users, noticing something's going wrong, shutting it off again, the time between those data points is a grand total of 1 second, right? And so literally their mean time to detect and mean time to resolve is inside of a second. So when a user has a bad page and hits refresh, it's gone, right? I don't really know how they pull that off, but that's pretty amazing. The basic idea, though, if you could fix something within 5 minutes and not have more than a handful of people affected, you'd probably be very happy. Like it doesn't have to be inside of a second, but high bar. So the last one is they use experimentation to validate ideas, right? So given what we've seen, we believe that if we change this, that will happen. So I just gave you the highly complex formula, which is based on what we already know. We believe if we do this, that will happen. So now you know what you're going to do and you know what to watch for. Like we're trying to make this move or something happen, right? So to validate ideas. So they like to measure the impact changes have, and every change always has a clear objective, right? So they know what they're trying to accomplish, and they actually write it down. And that lets them to validate what they're doing. Either they achieved or they didn't achieve, right? So Lean Startup is a book about how to run like a lean startup no matter what size you are. And instead of making complex plans that are based on a lot of assumptions, you can make constant adjustments with a steering wheel called the build, measure, learn, feedback loop. This is, again, how do I do things fast and learn, right? I think the way they put this is actually more interesting. The quicker we manage to validate, this is a quality of life thing, by the way, if you watch between the lines, the quicker we manage to validate new ideas, the less time is wasted on things that don't work, and the more time is left to work on things that make a difference. This way, experiments help us decide what we should ask, test, and build next, and spend less time on 6-month projects that get shelved, right? Time check. Okay, I'm going to get a 5-minute mark when we're near the last 5, right? Excellent, cool. So I love the story, Lukas Vermeer. Kind of what's hip in the DevOps space is people telling stories of how they failed. They don't always, pound their chest and say we're awesome. So he was hired to be a very smart data scientist, and they had this page that if you had a search query on Google, you'd end up in this landing page that would show you hotels in Asia, right? And it had this list for each of the cities. It would have 5 hotels, and he said, well, I'm going to optimize this page. Those 5 hotels we're selecting, we need to find the smartest way to select those 5 hotels so that people will book more trips. And so we spent 6 months literally changing the order of the hotels and figuring, do I do the ones most people booked, or the ones that have the highest ratings? What do I do? Tried all sorts of things, and nothing changed. Had no effect on the conversion rate at all, 0, zip. And he got really frustrated and said, I'm going to move on to something else. And somebody at work said, hey, before you do that, let's just do a quick HTML hack and hide the list of hotels. They actually dug into it a little more and they thought, what, people aren't really clicking on the hotels. They're not clicking on the hotels. So let's just turn them off and see if anything happens. So they turned off the individual lists of the hotels, right? And the impact was nothing. Okay, another experiment, impact was nothing. Is that a failure? Is that a learning? Don't know, but nothing, right? And they said, okay, I am totally dejected. I'm out of here. And the developer said, hey, whoa. All that smart data science stuff you put into the back end there, let's pull that out before we move on. We're going to shut off that list. Let's actually not just do an HTML hack. Let's make sure we don't do all that calculation. Oh yeah, sure, fine. So they wrapped that in an experiment. And when they did, they found the conversions went up. When they just did the back end change to the code, which had no impact on the page view, but why was it, did anyone want to guess why conversions went up when they changed the back end code? Quicker. Yes, right answer. It was faster, right? So it was just a little bit faster, and so more people liked that. They were all going to that search box on the top left anyway, and when it came up faster, more people used the service and booked. So literally, kind of a messy story, but the fact that they wrap everything in the experiment meant that they got to the good thing without it just being kind of crazy chaos, right? The last one I'm going to cover, and then we'll get into the takeaways and kind of wrap things up. So Facebook Gatekeeper. I don't know if anybody's heard of Gatekeeper. We've all heard of Facebook. Some of you might like Facebook. Some of you might not like Facebook. It was where I did all my family photos for a very long time. Now I have a private way to do that, and I'm happier with that. But they have had to cope with scale from very, very early on. And the way they chose to deal with scale wasn't to have lots of rules and lots of structure and lots of change committees and that kind of stuff. It was the reverse, which is they sort of promoted chaos, but found a way to kind of get through it, right? And there's an article Kent Beck wrote called Taming Complexity with Reversibility. And you'll notice there's a 4-headed monster, right? So they said, we looked at complexity, and we saw that there were 4 things. There was the complexity of states. Knowing what state a multi-part system is in is very hard. If you've already gone through the journey of like microservices or whatever, knowing the state of everything all the time is really, really tough. Interdependencies, understanding all the interdependencies of a bazillion different parts is actually really, really hard. And uncertainty, the world's an uncertain place, things will happen. So understanding what's going to happen and how to cope with it, that's actually really hard. But then they stumbled on this, they said irreversibility, let's look at that. And a less fancy word for irreversibility is how do I get an undo button? How do I make, if something bad happens, how do I make it that I can reverse it? Like just make it unbad. Thanks. So that's what they focused on. And the way they did it was they would do dog fooding. So actually, Facebook uses their own product a lot internally. And so instead of coordinating the teams, they actually just let all the teams do what they do, and everybody pushes to an internal users. And people, if their own thing breaks, they say, hey, who did what? And it stops it from progressing, right? But if after an hour nobody speaks up and says you broke something, then it starts to propagate. They then deploy out to, I think it's 2% of the population, but you're Facebook, right? So that's millions of people, right? So they deploy out to a larger population. It's a staged rollout, a little bit at a time, and they go bigger and bigger and bigger. They do this by having a dynamic configuration. They don't do this by bringing up servers and shutting down servers. They do this by the ability to sort of dynamically control what the system is doing. And that's the pattern we're talking about, right? And what I love here is, we can dial up features up and down in tiny increments like 0.1% to figure out the weird interdependencies of complex stuff. So they have the ability to have a lot of control over this. And then The last thing is correlation. Our correlation tools, and this is really the key thing, right? This is the part that shouldn't be ad hoc. Our correlation tools let us easily see the unexpected consequences of features, so we know to turn them off even when those consequences aren't obvious, right? So they have the ability to watch and see what's happening. So those are the real life stories that I shared, and if you ask for a copy of the deck, you can get the URLs and stuff. Let's just quickly do the takeaways, and then we'll have a couple more minutes left. So first one is decouple deployment from release. Figure out a way to make deployment not release, okay? And when you do this, deployment is just infrastructure, just moving bits around, okay? Release is exposing bits to users. Now let's just look at kind of a data flow of how you might do that. So there's your app. There's something outside your app that's controlling what your app does. And in this case, you've got an SDK that is part of this sort of feature flagging system, right? And anytime you want to run your code, you ask, hey, which version should I give? This is the related post thing again, right? And you have your rollout plan is controlled external. This is really important. It's not about pushing a new configuration file. It's not about changing your code. It's about how do you externalize the controls somehow and push those rules into the app whenever you want, without having to redeploy the app, right? And when you do this, keep it fresh, right? Then you have the ability to actually, every time, I'll go back if you want to take a picture. You got it? Good. So you have the ability to have this control. And a question I get is, where should you implement progressive delivery controls, the front end or the back end, right? Because people say, well, do you do this in the browser? Do you do this? Where do you do this? And basically, you want to do it, you kind of want to favor as far back as possible so that the user's not involved. There's actually a fun little story about a woman who figured out that Facebook was using feature flags and turned on a feature was for dating before they had announced it and took a screenshot. So she literally went into the browser tools and just flipped the value of something, and in her browser there was the dating thing in Facebook, and she put it on put it on Twitter, right? And they weren't too happy about this, but that's because they were using they were switching it in the front end, right? There are reasons why you might sometimes want to do the front end, but the closer to the back, the more you can kind of use high-powered infrastructure and not involve latencies to the user and stuff, right? Build-in observability, so know what's rolling out and who's getting what and why. Align your metrics to the control plane. So if you're sending some people this way and some people that way, don't use global metrics to watch. You want something that's watching the same way, right? You're looking through the same lens as the different populations, right? Make it easy to watch guardrail metrics without work. So don't say, we should all keep track of all these things. No, make it a non-brainer so for people to actually just, oh, you get this thing that tells you whether there's a response time issue or you're causing problems, right? So how you might do that, again, your app goes to do this. You send out a note that says, hey, Bob came through, he got this treatment for that reason at this time, and per this rule or whatever. And then you ingest events from wherever you can get them that basically say, hey, by the way, Bob came by, he was kind of angry, he canceled his account, and or Bob bought more things, or Bob had a really slow paid response time, right? So how do I ingest things with that same key, Bob, and know how it went, right? So this sounds kind of complex, but there's only two pieces of data you really need. One is a unique ID that was used for the decision, Bob, it would probably be a GUID or something, and then when did it happen? As long as you know those two things, you can actually correlate back to, was it related to this experiment, right? And the last thing, and I'm going to run late, so I'm going to wrap this up really quick. Going beyond MVP yields significant benefits. So a lot of people say, well, we have a system in-house that does some of this already. Well, if you look at the stories from these other companies, they evolved and evolved and evolved to the point where they have a really amazing thing that works great for them. But most people I talk to at shows like this will say, I have no way to analyze automatically, and so there I am, I'm doing it by hand. So build it for scale, make it stick, right? So I'm done. I just want to leave you with one last thought, which is, whatever you are, try to be a good one. This is a quote from William Makepeace Thackeray. And this is, if you're going to do something, like just do the thing, do it well. I hope that the ideas I've shared will let you change how you do what you do. Those of you that want to go build something that does this, I hope this helps you go build something that does this. Those of you that want to look for a commercial solution, I hope you'll come by and talk to the folks at the Split booth. And if you just want to brainstorm with us about how this stuff works and have a beer, that's cool too. I'm not here to sell something. So I hope that's been useful, and we got a wrap. Thank you very much.